period?
Yeah, I just
All
want
right.
to get my binder.
If you can get it done by student advisement period, then we're good.
Mr. Charrier, I don't have my homework. Take
Not
me
right now.
2 seconds.
No. All right. Good morning, e-learners. Good morning, e-learners. Oh, looks like we got Winter in class today.
Hey, what's up, Winter?
Hold on. She hasn't logged on. She is connecting to audio. Can't hear you yet, so maybe she can see you. All right, wave to Winter.
Hey,
Winter.
All right, for the rest of you, questions on the homework. You didn't get number what? 8 through 12? Literally, you didn't get 8 through 12?
It was hard. Letter always is big.
this is the easiest homework.
8 through 12.
Ouch. What do you mean?
Dang. All right. 8, 10, 12. Those are the ones I didn't understand.
So, do you see what that says?
Yes, I understand that now, but I don't understand.
Okay. Yeah, but I'm saying, you see this?
Yes, I do. That's
an expanded
That's
form.
400.07.
Right, so I'm saying this is an expanded form.
Yeah.
They want you to do this process to that number. So that would be 3 times
3 times 10 plus 8.
plus 8 times 1. Now, if you noticed in the book for the ones place, they did not, they wouldn't say like 8 times 1, they would just say plus 8. And I just said, hey, let's just follow the pattern of, well, if they multiply 3 times 10, why don't they do the same thing for the ones? So that would be the only difference. All right, anyone think they got one wrong? What do you think you got wrong? Give me one you want to check. Okay, so I will call out the evens. Here we go. Jenna, make sure you turn your homework in from Friday, which you should be turning in today. When we get there. All right, number 2. 2 times 100 plus 5 times 10 plus 6 times 1. Number 4, 4 times 0.01 plus 7 times I'm gonna start saying leading zeros now. Times 0.01. Wait, I just read out 5. Never mind. Never mind.
I told Jackson the wrong homework.
Number 4 is 5 times 1. All right. Number 6. Stay with me, please. 2 times 10 plus 8 times 1 plus 4 times 0.1. Number 8. 9 times 1 plus 7 times 0.01. Number 10. 5 times 1 plus 5 times 0.1. We good? Yes.
Remember, where did 5 times 10 to the 0 power?
Ooh, even better. I didn't have anyone do that, but that's true. She said 5 times 10 to the 0 power. Impressive. All right. But notice none of the other ones I had you multiplied by exponents, but what you said is fine. All right, number 12, 400.0732. Number 14, 193.023. Now, if I read those correctly, number 12 is 400 and 732 10,000ths.
What?
Yeah. Wait.
If I read it.
Wow.
Number 14 would be 193 and 23 thousandths.
What number?
That was 14. Now, I already read those answers out, but I read them in just calling out the numbers and their places. Okay, picking up on number 16, 11.4, 11 and 4 tenths. Number 18, 0.0037 or 37 10,000ths. Number 20, 5.06 or 5 and 600ths. Number 22, 94.0007 or 94 and 7 10,000ths. All right, we're on math gang symbols. 24 is greater than 26 is less than. 28 is less than. 30 is less than. 32 is, there's a lot of less thans. Less than.
What? I agree with you.
43 plus 17. I'm sorry. 17 and 28 is bigger than 43.
5. I don't agree with you.
You get 45 and 43. 43 is smaller than 45. 34 is equal. 36 is less than. But 38 is greater than.
What?
All right. Make sure your names are on those. Gracie's coming around to collect.
34.
Correction's passing out. The rest of you are copying down your homework.
Okay.
Winter, are you with me now?
What was that?
I'll turn up the volume just in case she was talking and couldn't hear.
Okay.
Apparently Winter doesn't want to talk to us.
Mr. Sharia,
Yes.
Can I go do my homework now?
No.
Where are we? I
End
need
of
to
class.
get my notebook.
End of class.
Oh. Oh, this is easy.
Okay. Now listen carefully. Christian, do you know how to round? Could you teach the class?
I could.
Yes or no? Okay, my claim is this. Listen, please. If I ask you, do you know something? I followed up, well, could you teach the class? The kid that knows how to do something would say immediately, yeah, I can do that. Okay? I'm not going to ask you to literally teach the class. My claim is that you don't know it unless you can teach it, right? So how many right now could teach rounding to the person next to them?
Oh.
Okay? Notice, look around. I don't see every hand up in the air. That's why this is a class in course 2. You will not get this class ever again. The last time you will ever get a class on rounding. You are supposed to have had this mastered before you get to 8th grade. So it's nothing new. I'm going to teach you nothing new that you haven't been taught before today. It's just rounding. Yes, I see plenty of rounding mistakes. So does Mr. Surratt in science class. Science class uses rounding quite frequently. Right? Math class uses rounding infrequently. Typically on a word problem, you might see some rounding, but almost everything that we do in math class does not involve rounding. Almost. Right? Say what?
It's
frozen.
Okay, I haven't clicked it yet.
But you said copy of homework.
I did?
Yeah, you did.
All right, I'm losing it. Sorry.
Yeah. Whoa.
There you go.
I know.
So, yes, I will make all of you listening to a rounding class today. For those of you that already know how to do this, great. One more time, last time of your life, hopefully. Yes,
Can we
unless you fail 8th grade.
can we listen to you?
Remember, if you choose to do your homework while I teach, you must not follow the Landon method, right? But you must have this filled out as we talk. And I will still call on you. But yes, you may do what you just asked. You ready? All right, here we go. Rounding. Basically how to round a number. All right. And I literally started off this class by asking Christian if he wanted to teach the class. He refused, so you all get the class. All right, from me instead of Christian. So rounding. First and foremost, Gabby, why do we round?
Because if it's like a decimal and it's like 20,000 like numbers, you just round.
There are times in math, she's correct, there are times in math and in science when our precision, how precise we want to be, doesn't particularly matter. I just need a number. Hey, your mom says, go to the store and buy some eggs, right? Well, eggs only come in a box of 12 or 6. Maybe they come in 4, but I've never seen that. So if you need to buy eggs, you got to buy in boxes of 12. Your mom has a recipe. She needs 37 eggs. Guess how many cartons of eggs you're going to buy?
3.
You buy 3, you bought 36 eggs. Your mom can't make you cookies. You're going to have to buy 4. So this idea of rounding up, rounding down, comes into play. Now today, we're going to learn classical rounding. The scenario I just described to you, hey, 37 eggs are required, but they come in boxes of 12, so I need to buy 4. That's rounding up, right? That's not classical rounding, right? That's, I'm rounding to the next largest value that I need in order to buy something. Today, we're just going to learn your classical rounding. We look at a decimal number, and we round. Now, it doesn't have to be a decimal number. It could be a whole number, okay? But that is why we round. It's generally stated, we need an approximation. Approximation is not precise, right? It's not the exact value, but it's close enough. Right? It's certainly faster when we have calculations involved. One thing I want you to remember from this class is, generally speaking, you only round as your last step of a calculation. Why do we not want to round in our first step?
Because then you could get an answer.
Every time you round, you become less precise. So if you're rounding as your first step and you have 4 calculations to do, that error, and it is an error, now is multiplied 3 more times if you have 4 steps. Okay? So we generally save rounding always for your last step. Okay. Warning.
Danger, Will Robinson. Danger. No, Will Robinson. Danger.
The warning is this. Every time you round, you introduce error into your calculation. I mean, you're straight up getting a wrong answer, right? Wrong in the sense that it's not as precise as it should be, right? It induces or it puts into your calculation inaccuracy. And that's fine, right? For instance, the egg scenario I just gave you. But you need to make sure you choose wisely when you round. You can only round in my class when it says round your answer. Or you say, Mr. C, can I round this one? And I say, go for it. Like I said, typically rounding would be in a word problem. Obviously today, every single question is going to be rounded. But we don't just round because we want to round. Oh, it's a decimal number. I don't want to do that long division. Let me round it. Okay, you're going to get an answer, and it's going to be close, but it certainly won't be accurate. Yeah.
But like, what if it's like 14 divided by, like, I don't know, 6?
Yeah, 14 divided by 6, and you don't really care that the answer is 2 point something. You're like, is it 2 or 3? Either one's a fine answer, and that's when we're okay with rounding. But there's other times when we want the precise. We say, math, the exact answer. We don't want to do any rounding. Today's not that day. Today we're rounding every single problem. Rounding should be your last step, and I've said that. Okay, is there a symbol for rounding? Yes, Mr. C, there is.
Oh, I know it. It's the curvy lines.
Right.
It's like
We on your keyboard it's called the tilde symbol, but in math we call it the approximation. Right. These 2 little curvy lines, 1 tilde, 2 tilde, right? That's called the approximation symbol. So in math, it looks like an equal sign that's all bent up, right? Kind of gives you the same idea. Well, it's not really equal to that number. It's sort of kind of close to that number. Okay? That is not the opposite of equal, but those are the 2. This is the equal symbol. This is the approximation symbol. If you round, you must show the reader that you just rounded, meaning that you have to use that symbol. Hey, last year, course 1, when did we use that symbol? Remember? Had to deal with that thing.
circle.
Why did we use that symbol when we deal with circles? Because pi is not 3.14,
Oh, yeah.
but it's close. You rounded pi to 3.14, and that's why every calculation we did that involved circles, circumference, area. Did we do volume of a cylinder? I don't remember.
Yeah.
Okay, all of those involve the approximation symbol. Okay, so that just means approximately. That means equals. That means exactly. All right, I'm going to scare you and write rules. How many right now don't need the rules for rounding? I do not need the rules. Well, that's not everyone's hand. So, step 1, write these down. Box 1. These are the rules. Step number 1, you must determine what's called the significant digit. Tonight for homework, it will say round to the nearest 10. Yesterday's last class, we had a class on place values. You know where the tens are. That's questions 1 through 8. Questions 9 through 16 says round to the nearest 100th. That is what's called the significant digit. That is the number that you are rounding to. Not TWO, but TO. That's step 1. So determine the significant digit. Well, if you are doing the rounding, right, you're not prompted to do it, you get to determine. Okay? Step number 2. This is the one that you will screw up. We don't look to the left. We look to the right of the significant digit. We're looking to the number that's immediately to the right of the significant digit. For those of you that are rounding experts, make sure you stop me if I make a mistake here. We're going to look to the right of the significant digit. So I determine what the significant digit is. It'll tell us, hey, round to the nearest 10th, round to the nearest 100th, round to the nearest hundreds place. Then I'm going to look immediately to the number to the right of that number. Yes. Say again.
Left.
One more time.
Left.
No, we look to the right. We don't look to the left. Like I said, this is the number one mistake you make, is you look to the left. We're not looking to the left. I should make this bold and red. We're going to look to the right. Step number 3. So you're looking at that number to the right of the significant digit. That number is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. If the number is 0 to 4, right? In other words, less than or equal to 5. If the number is 0 to 4, we do nothing. But if the number is 5, 6, 7, 8, or 9, now we go back to the significant digit and we increase it by 1. Add 1. Does this all sound familiar? People don't forget this step, step 3. They forget step 2, and they look to the left. You look to the right. Step number 4. I'm sorry, I forgot to put that one. So if the number is 0, 1, 2, 3, or 4, you do nothing to the significant digit. If it's 5, 6, 7, 8, or 9, in other words, 5 or greater, then you go to the significant digit and it increases by 1. That literally means if the significant digit was a 9, it now becomes a 10. Well, that can cause some problems. We'll look at that. That's the classic one that all math teachers put on there. They put a bunch of 9s there. Forces you to keep carrying 1 and carrying 1 and carrying 1. All right, step number 4 is you erase all the numbers to the right of the significant digit. Or add zeros. If we're talking about decimal numbers, it's erasing. If we're talking about whole numbers, that's when we do this thing called adding zeros. We're not technically adding zeros, we're just making all the non-significant digit numbers to the right zeros. Does this sound familiar? I'm going to leave this up here. So for those of you that are slow copiers, I'm moving on to examples, but it will still be on the board. Yes? Here we go. All right. So, Amanda, read it, what it says. Round and there's 10th. So they are telling you step 1. Tonight for homework, they will tell you step 1. They will tell you what the significant digit is. It says not round and nearest tens place. It says round and nearest 10th place. So either remember what we learned from yesterday, or maybe you have that sheet from yesterday. Which one is the 10th place, Amanda? 3, 2, 4, 5, or 7? The 10th is the 5 is the hundredths place. The 7 is the thousandths place. 4 is your 10th place. You see what I did there? I made an arrow. Maybe you want to underline it, potentially. That's your significant digit. Step number 2 says what? Look left or look right? Says look to the right. What number is immediately to the right? A 5. Okay. Now we're on step 3. Hey, this number is either going to be 5 or more or 4 or less. You probably had a teacher that told you some saying, right? 5 or more, give it a shove, 4 or below, leave it, I don't know. Whatever those sayings are. I don't have one of those cool sayings. I have a rule. It says if it's 5 or more, the significant digit increases by 1. If it's 4 or less, leave everything alone. Hey, is that a 5 or more? Yes or no? Is this a 5 or more? It is. So I go back to my significant digit, it increases by 1. This 4 now becomes a 5, and step 4 says to erase everything to the right. See what I did? This adding zeros is when I'm rounding to something that's a whole number, right? Round to the nearest tens or hundreds or thousands place. I put the 2 wiggles right here because it's an approximation. That number isn't 32.5, by the way, but it's close. All right, is that brand new to, please be honest, is that brand new to anyone? All right, I will go as fast as you want me to, okay? If I'm going too fast, it is your job to slow me down. As I started the class, this is not new for 8th graders, this is a review. All right, same number. This time, however, we're going to round to the nearest 100. Which digit is in the hundredths place? The 5 is in the hundredths place. So therefore, we look to the right, or we're always looking to the right. Hey, is this number 5 or more? Yes or no? It is. So therefore, the 5 now becomes goes up by 1, becomes a 6. I erase the 7. Why? Because it's not a significant digit. You're either going to be erasing the non-significant numbers to the right, or you're going to be making them zeros. Technically, you're always making them zeros. We just choose not to write the zeros. It would be a lot of zeros, right? Okay. One more time. Notice what we're rounding to. What are we rounding to? Not the tenths, not the hundredths, not the thousandths. We're rounding to the nearest tens place. Which digit is in the tens place? 3. We always look to the right. So what number is that? That's 2. Hey, is 2 5 or more? Yes or no? It is not. When it's not 5 or more, you do nothing. Immediately go to the next step. The next step says to erase all the numbers to the right. That would be from 2 over. Except sometimes it says to add zeros. Here's the case where we add zeros. At 2 now, if we erase it, now the answer is 3. That doesn't make any sense, right? So that means this 2 is now a 0. That means all of these numbers are zeros. We just choose not to write the decimal numbers as zeros. So this now becomes 30. I'm sure that a 4th or 5th grade teacher who introduces does a better job of teaching this than me. But there's my shot at teaching you how to round. Hey, is this number 30? Is this number 30? No, but it's close, right? It's 32 and some change. So it's not 30, but it's close. If your mom says go to the store and I need about 32 eggs and you buy 30, is your mom going to be happy? No. She might be because she said about. But if your mom says she needs 32 eggs for the recipe and you buy 30, is she going to be happy? No. Be careful when you round. They're going to throw eggs at you, yes.
Oh, that's funny. I got a good story about that.
Here we go, box 2. Box 2. We are going to be rounding all 3 numbers to the nearest 10th. Do it. I'll give you a 15-second head start, and then I'm going to help you out. If Landon makes, what, 1 or 2 mistakes? How many mistakes are we going to give him?
1. 1.
No, Jaden, you're influenced by the fact you're carrying his 50-pound rucksack.
Actually, he forgot today, so I've been 3.
I didn't forget. I was giving you grace.
Jen, 2.
All right. I'll give you 2 mistakes on the entire page.
What's this mistakes?
You get it wrong.
Oh.
Did you literally just ask what are mistakes?
No, I didn't understand.
What? No way. Mistakes are
I have
mistakes.
excuses.
All right.
Crazy.
Are we already done?
Yes.
Well, not everyone. Some people still working. Who needs help? All right. Let's start in the back. Priscilla, first one. What's the final answer? 16.1. Is she right?
Yeah.
All right. So typically I would go through all the steps, but I'm going to go with just the answers. You got to be brave. You know, like, wait a minute, help me out. that sort of thing, or we're just gonna go with answers, since we're doing rounding. So 16.1 is what I got as well too. All right, number 2, the middle one,
105.1.
105.1, yes, no?
Yeah.
That's what I got as well too. And then number 3, Christian. What? 0.6. What's the significant digit? Okay, the 6. We look to the right, it's a 1, therefore it's not 5 or more, so we do nothing, we just erase all the digits. So, right. All right, we got this? Yes. Sure. All right. You want to do 3 more? Yeah, let's do 3 more. All right, round these to the nearest hundredth. Round these to the nearest hundredth. Hundredth. Yes, I'm using the same numbers over and over and over again. We're gonna find out.
But I hope that's right.
We're gonna find out. Why do you have 2 answers on some of these?
So I thought it was the same thing, so I was like, oh, you got this wrong, but then I realized it was
So which is the answer? The one on the right or the one on the left?
the one that I circled.
You circled 2 though.
What is this?
Which
The one on the right.
one on the right? Okay. All right, who we lead off on? Gabby? Go, first one. 16.1. Now, why didn't she say 16.10? Wouldn't that be rounding to the nearest hundredth?
Because the zeros are not necessary.
You agree? Yeah. So it would not be, I mean, I wouldn't mark it wrong if you put 16.10. It's just not necessary. So 16.1. Are you guys remembering to put the wiggles? Because Landon's not. So make sure you put the approximation symbol. All right, next. Hannah, middle one.
105.12.
Can you read that the way it's supposed to be written?
Oh.
105 and?
And 12.
Perfect. 105 and 12 hundredths. Good job. All right, and the last one, Jenna. Which digit is a significant digit? This is step 1. Which digit is in the hundredths place? 1. Okay. What number is to the right of 1? 5, she said. Is 5 5 or more? Yes or no? It is. So what do we do with the 1? Remove it. Read step number, was it 3? Well, you might think that, but that to me doesn't mean add 1. Step 3 says if it's 5 or more, we add 1. Now she's doing that. Yes. So that 1 now becomes a 2. What's the final answer? We're going to do this all hand and arm signal today. 0. Keep talking. Point. You got to give you something. 0.6. What? 2. All right.
No.
Landon, you got that one wrong.
How?
All right. Let's do 3 more. This time around the nearest 10, not 10, 10. Yes.
Can I go to my backpack and get some tons?
Sure, go. Jenna, yes, no? You know what you're doing? Want me to watch you do some? Yes or no? All right, then get them done. And then I'm going to come back and check your work. Are you already done, Con? Where's your approximation symbols? All right, we're going to move all the way over to Avery. Avery, the first one, what'd you get?
I got
7?
7. I mean,
All right, Avery, what's the significant digit here?
70.
What's the significant digit here?
1.
1. So you're starting off strong. What's the number to the right of it?
6.
is 6, 5, or more.
It's more.
So we go back to the significant digit and do what?
You add.
So therefore we get
Two.
2. So what's the final answer?
Two.
But this now becomes a 20. The ones that will get you into trouble, the ones that say to round and nearest 10. Whole number means, by the way, if it says round and nearest whole number, it means the ones place. Are you listening? You see instruction says round to the nearest whole number, that means the ones place. Why do they say the ones place? But you'll see it.
It's 10,
10,
100.
100, thousands, those are the ones that will give you problems. All right, go, Jace, middle one.
Middle one. Okay. 110.
110. Notice everything else becomes zeros. Go ahead. What do you think the answer is? Take a guess. Okay, well, let's see. What's the significant digit here? Is there a tens place in the last one? Yes or no? Is there a number in the tens place? Well, there is. Guess what that number is?
0.
That number would be 0, right? So that's the significant digit. What number is to the right of it?
0.
Is 0 bigger than 5?
No.
If it's not bigger than 5, what do we do with the 0?
Add 0.
Leave it alone. Therefore, the answer must be. There you go.
I got all of them.
Well, the statement I got them all right, except is not. Kind of negates that first part of it. I got them all right, except. All right. We okay? All right, let's do 3 more and call it almost a day. Okay? Some people already done the whole sheet. I'm trying to accommodate them. Other people are still working. Thank you for giving me input that I didn't ask for, Jim. I'll always appreciate it. You think it's right? You want to make a bet?
No.
No? Okay.
Give my bag
You
to
have
them.
learned, young grasshopper.
Oh, wait, no. Jaden.
Last year, Jaden would make this bet frequently, and he lost. Landon made this bet frequently. He lost nearly every time.
Yeah, like
Nearly.
As soon as the homework involves like more than like 5 or 10, probably it's not a wise bet.
Wait, am I still grounded from the Rubik's Cube?
You're grounded for life from the Rubik's Cube.
All right,
Like you are.
here we go. We left off with go first one. 36.1. Is that right? That is correct. All right. Next, Jaden. Boys. Yeah, maybe because they're trying to tell you that you need to have your sheet out in front of you.
Yeah, Jaden.
Well, let's see if you can. Round to nearest 10th.
0.
Absolutely wrong.
What it is?
No, it's not.
0.
Okay, Jaden, what's the significant digit?
I was reading 10. It's 9, 5, so it's 1. 101.
Is that your final answer?
Yes.
Well, 101 is correct. 101. So this is your standard math teacher, the ones that have the 9s in them, right? So you got to be careful. Remember, the significant digit here was 9. We look to the right, it is bigger, or 5 or bigger. That means this 9 goes increasing one, which makes it technically a 10, but we write 0, and we move that 1 to the next number over. 0 plus 1 is 1. So 101 is the answer. Who's lost on that one? It's usually the 9s that cause problems. All right, and then the last one, Amanda. Round the nearest 10th place. What number is in the 10th place? The what? 10th place is right smack here. 0. So we look to the right. What's that number? Is it 5 or more? Yes or no? Therefore, we do nothing. We leave everything alone. Those all become 0. So the answer is 0. You put 0.0. Okay, that's fine. All right, we do need to do one more thing. One more thing. This is called estimating an answer. There are times in science, there are times in math. Are you listening? It looks like you're packing up. There are times in math and science when you don't need an exact answer. You just need an approximation. This is a very adult thing. We do this all the time. We have some math to do, and we know we don't need to be precise. Human beings, adults, you as well, will do the math quickly. It's kind of something that you maybe potentially can do in your head. Let's see. Oh, I need to buy the new PlayStation. They say it's going to be about $500. If I save, I don't know, $52 a week, for so much, then let's just round that to 50. Oh, I can do that math pretty quickly in my head. 50 to get to 500, that would be 10 weeks that I need to save. 10 weeks at $50, right? That's kind of when you would use this thing called rounding. One, we just need an approximation, and it's certainly faster than adding 52 plus 52 plus 52, that sort of thing. Especially when there's a decimal involved.
Or when you go shopping, you have like a.
When you're going shopping, okay, now this isn't typically done, but it used to be that you paid with cash. And you had, I got $80, right? So I need to, when you're adding up your groceries so you don't go over $80, you basically round what you're buying so that you don't go over. Oh, the peaches cost 98 cents. Well, that's about $1, right? That's the technique and why you would use rounding in real life. It's certainly faster than adding 0.98. But
I know this has absolutely
then
nothing.
let's save it for the end. All right, quick example. See these two numbers? I can certainly, and so can you, add them up. But if I just need an approximation, 378 is awfully close to, and 53 is awfully close to, so it's about 450. Yes? Is it 450? No, but it's close. That's kind of the idea. Now you can get a more precise answer instead of rounding to the nearest hundreds place, round to the tens place. Well, that would be 380, and this would be 50, so therefore the actual answer is closer to, 430, right? So instead of 450, now we've made the answer closer to 430. We still don't have the precise or the exact answer, but depending upon what you round to, right, gets you closer to the exact answer. So just be careful. Well, what if I rounded to the nearest ones place? Well, if you did, then it would be 378 plus 53.
I think actually I did a little rough math on that. I think starting that 400 was actually more precise than.
Well, no, because 400 plus 50 is 450. The actual answer is closer to 430 than 450. Oh, what is the actual answer here? 441. So it's what, 9 away from 50, but what did I say? 450 versus 430. And what did you say the answer was? 441. So it's 11 away from 430. 450 actually turned out was a better approximation. But I will say this, when I did it, I was rounding this to the nearest 100 and that to the nearest tens place. Right? Yes?
I need to go to the bathroom.
Well, remember, if it's an emergency, you don't have to ask. All right. If we round each to the nearest hundreds place, look how far off we get, right? 53, well, 5 is, right? Big 5 or more, so you move the hundreds up by 1, 0 now becomes 1. We get way off, right? So you just have to be careful of what you round to. The actual answer, as we said, was 431. Right? Well, then you said the wrong answer.
But I'm right.
Well, what's 3 plus 8?
Oh wait,
3 plus 8?
I was using
3 plus 8?
11 plus 8, 11.
5 plus 7? 12 plus 1 is 3 minus 1.
So I don't know.
All right.
-1.
No, I don't think. All right. Okay, so general rules. Write this down, box 6. The general rules for math with estimation. Hey, if you have really, really, really big numbers, we're talking like millions, hundreds, thousands, we're not going to round those to the nearest tens place. That's crazy. If you are a millionaire, losing $10 here or there probably isn't a big deal. So if you have really, really, really big numbers, we're going to round to the second digit of the number. We're going to round 1,000,000 to the nearest 100,000. If you have really, really, really small numbers, lots of decimal, generally speaking, we round to the nearest tenths. These are general rules. These are not like you will always do this. But in general, round to the nearest tenths if you have decimal numbers. In general, if you got really big numbers, round to the second digit of the number. These would be rules for, they don't tell you in the book to round. You want to round. What should you do? Yeah, I'm just saying, if it says, what is the approximate answer, and they don't tell you what to round to, well, then you need some rules. Here are your general rules. Got a big number, round to the second digit of the number. Small numbers, just round to the nearest tenth. It would be rare that rounding to the nearest tenth isn't a good thing. Rare would be like in a manufacturing process. You got a machine that can actually cut or make things to the nearest thousandth of an inch or 100,000th of an inch. That's very precise. What?
So technically, if it's rounding, you could round that last digit, and it'll be an approximation because you round it, but it would be the exact same number.
Yeah. Just remember, when you do decimal long division, sometimes you can get some really crazy numbers. You can also get a repeating decimal, right? So when you get a repeating decimal and it's just a bunch of threes, right? Well, where do you round it? Well, let's just call the nearest tenth and call it a day, that sort of thing. 0.3 repeating is something 0.3. It's good enough, right? All right, so check it out. Crazy calculation, right? Big or small numbers here?
Big, small.
I heard both answers. Big or small numbers here? Small numbers. All right, so the general rule says round to the nearest tenth. Round that to the nearest tenth. Nearest tenth. Round to the nearest tenth.
Oh, 0.2.
How about 0.2?
Oh.
You look, remember, to the one to the right. So 0.8, we said that was, what's 2.8 minus 0.2? 2.8 minus 0.2.
2.6.
Notice, one of the reasons we do this rounding is because it allows for easy math. You just did this subtraction in your head. Notice I didn't ask you to write anything down. So I'm not saying that you should always do this, but when you can clearly get to an answer that's close, and that allows you to wrap your head around what is the answer. I don't know, 2.6. All right, so maybe if I buy 3 of those things, I'll be good to go because the answer is 2.6. All right, division as well, right? I don't know what the answer to that is off the top of my head, but I can use some rounding to help me out. Let's round to the nearest tens place.
250.
What does that round to?
250.
What does that round to?
25.
What's 250 divided by 10?
25.
I'm not claiming that the answer is exactly 25, but what I am claiming is that we could get to an answer pretty quickly. The answer is close to 25. Maybe it's a little less, maybe it's a little more. We know it's roughly 25. I got a bus that handles 40 people. Okay, one bus is good enough. But I didn't have to actually do that calculation, 253 divided by 12.
You need a proper bus.
You do, but if the bus holds 40 people, then one bus would be good enough. Hey, you met some friends. Just be careful. All right, let's do one. Here we go. Hey, multiplication. You're not going to see that symbol much more. 32.9 times 8.7. I'm reaching from a calculator. Most of you as well too, right? Or we can do some rounding.
30.
Let's round to the nearest ones or whole number. What does this number round to?
30.
What does that number round to?
9.
What's 30 times 9?
270.
What?
270.
200.
270.
270, yes?
Yes.
Right? If we round the nearest one place, we get 33. Not 30. Why 33 and not 30? Mr. Chartier's room. Abby, where you at? She just went to the bathroom. Got it. All right, bye. All right. Why is it 33 and not 30? Because when I said round this, and you said 30, you were actually rounding to the nearest tens place. So be careful. Well, you agreed with me, yes?
Math mistake.
So it wasn't
So it wasn't
270.
270.
297.
Well, then now, they're not doing this one, right? Okay, that's a little bit more challenge. So maybe,
297.
is it 297? So 7 carry your 2. 9 times 3 is 27 plus 2, 297. So 297. We got what, 270? Rounding that to the nearest tens place. So that's kind of far off, right? That's kind of far off. We okay? All right. All right, don't assume that I am correct ever. What are we going to round to here?
10.
About round the nearest tens place? Okay, let's round the nearest 10 place. This is an example of box 8. What do we get?
90.
What do we get?
10.
That would give us
10.
10.
tens place.
That's
900.
100.
What?
900. Because you said 90 and 10. That's 900. No, it's not.
Give me something to throw.
Hey.
Jaden, that was a classic. That was classic.
Here.
All right, so if we're rounding nearest 10 place, we get, Jaden, how much? 900 divided by 10.
100.
What?
Wait, addition.
Oh.
100. 100.
Oh my God.
No, he's right, but all right. No, we do in fact get 100. If we round different though, look what I'm doing here. If we round to different values, I'm rounding the 89.6 to the nearest 10 place. I'm rounding the other one to the nearest to the ones place or the units place or the whole number.
Rounding to 1.
Yeah, agreed. I'm just saying, see what happens, right? So just be careful what you choose. It's not that you can't do this. It just doesn't make much sense that you round 1 to the tens place and 1 to the ones place. So, I mean, be careful. Be careful. Tonight for homework, they give you on section B, so this would be questions. I'm going to skip this. We got to do some of those. They just say, what is the most reasonable answer? Okay. So you got to figure out what sounds like a reasonable. All right. What are we going to round to?
10.
Tens?
No, 1.
I would say ones. So that would be 60,
65.
and that would be
89.
9. 65 minus 9 is
54. 54.
50. 65 minus 9.
56. 54.
56. 56.
It's like we get wrong answer, wrong answer, wrong. You like you guys would trade them. All right, stop. I just want to make sure. Hey, before we leave, are we okay of doing this all by yourself?
Yes.
All right, see you tomorrow.
56.
Yes. Oh, thank you. Abby, come here.
65 minus 9. 56.
Abby. All right, e-learners, that's it for today. If you have any questions, send me an email. You're going home. Somebody's coming to pick you up.
Are they here right now?
They will tell you when they're